In our conversation on mathematical rigor, I made the claim that there was a hidden issue with Euclid's procedure for constructing an equilateral triangle on a segment. So just so we're all on the same page, the process is pretty straightforward. You draw two circles whose radii are the same length as the segment and whose centers are at the endpoints. Then you connect the point where the circles intersect with the two endpoints of the segment, and you got your equilateral triangle. The trouble is with that intersection point. It might not exist depending on your assumptions. And that's where we run into rigor problems. The definition of a circle, which Euclid never actually gives, by the way, but that's a topic for another day, is the set of all points of fixed distance from a central point. And it's the distance part that's going to cause trouble. To make this happen, we have to have a way to define the distance between 2 points. And to do that, we have to have a way to define the location of 2 points. Now, in modern terms, we usually do that with coordinates. And if you let those coordinates be real numbers, then everything is fine. The intersection point has to exist, and you've got your triangle. But suppose your coordinates can only be rational numbers. There's fractions and integers. No square roots allowed. All right, now you're in trouble, because even in the simple case, where the length of the segment is 1, locating the intersection is going to require an irrational number. And those don't exist in our rational limited world. Now, okay, you're probably thinking, what kind of lunatic would define a coordinate system that way? And the answer is an ancient Greek, like Euclid. The ancient Greeks had a real hate-hate relationship with irrational numbers. They built this whole philosophical mathematical worldview around the idea that every number could be written as the ratio of two integers, that is, as a rational number. And they were not happy when they realized they were wrong. So it isn't at all unreasonable to think that Euclid, if he had had coordinate geometry to work with, would have limited it to rational numbers, rational coordinates. Okay, but the real point here is that for Euclid's procedure to work, you have to have a clear idea of what distance means and how you can figure out the distance between 2 points and what sort of values you're going to allow. Now, yes, it's very inside math, but it's the kind of detail that modern mathematicians obsess over because we've learned exactly how wrong our results can be if we don't. So if you haven't watched our discussion of mathematical rigor where I first talked about this, the link to the left will take you there. And if you like this or found it interesting, please don't forget to click on the like button down below.